Okay, introduction to triangles, our first glimpse of triangles in this course. Well, of course, you've already seen triangles your whole life, but in this course, we are going to talk about triangles, and in the next unit, our whole unit will be dedicated to triangles for Unit 5. But for now, we're going to start with the basics. You've already heard of this stuff before, probably like in middle school or so, but we're going to start off by classifying triangles by their angles, okay? So let's go ahead and take a look at acute triangle. An acute triangle is basically this. These angles have to be acute. This has to be acute, this has to be acute, this has to be acute, okay? And remember, with the word acute, right, it means that it's less than 90. The angle is less than 90 degrees, okay? So again, this has to be less than 90, this has to be less than 90, and this has to be less than 90, which means that if that's the case, then this is an acute triangle, okay? Equal angular triangle. Well, equal angular, well, it's in the name, right? Equal angles. Equal angles triangle, or equal angle triangle, where these angles must be congruent acute angles, okay? Well, how long are these angles? And they have to be the same because they are three congruent acute angles, right? So remember, if I ask you, well, how many degrees in total is a triangle? Well, you would tell me it's 180 degrees, right? And if these angles are equal, right, you have to divide the 180 equally, meaning that this here is 60, this here is 60, and this here is also 60 degrees, right? So 60 plus 60 plus 60 is equal to 180. And notice the fact that this is these angles here are acute because it's less than 90. So there you go, equal angular. And the obtuse triangle. With an obtuse triangle, you have to have one obtuse angle, and obtuse means that it's greater than 90 but less than 180. So here is the fat angle, and if you have one fat angle, then the whole triangle is obtuse. The right triangle. The right triangle, you have to have one right angle, and it has to be 90 degrees. If you see this square, or sometimes you have to draw the square if it's necessary, it depends on the situation, but in this case, if it's one triangle and it says that it is 90 degrees, then it is a right angle, okay? And I will get into the part where I'm like, oh, well, there isn't a square. Do I draw the square? Well, yes, it depends on the situation, or if not, then don't worry about it. It will tell you, or sometimes it doesn't, and if it doesn't, don't assume it's a right triangle unless you are given some sort of special circumstance, if that makes sense, okay? We'll get into notes and then everything will start making sense, okay? The classification of triangles by their sides, okay? So, this word, equilateral, right? Equilateral means you have three congruent sides. Equilateral. Lateral, I think that's like a, it's just another way of saying sides, right? I think that's like, is that Greek? I don't remember. But lateral just means it's just another word for saying sides. So lateral means like sides. So you have equal sides, therefore it's an equilateral triangle. So three congruent sides. Isosceles triangles, that means that you have to have at least two congruent sides, okay? So this side and this side are congruent, and this side is that lonely one, okay? This is an example of an isosceles triangle. Now, if I were to say at least, right? Well, at least two congruent sides. Would I say that an equilateral triangle is isosceles? Yes, because it has at least two congruent sides. So an equilateral is also isosceles, but an isosceles triangle is not equilateral, okay? And the scalene triangle means no congruent sides. No congruent sides, okay? All right, example 1. Classify the triangles in the figure by its angle. Triangle PQS, okay? So how I like to read this, it's like reading an angle, but you're going to close it. So here's PQS. I'm going to go in order. Here is triangle PQS, and then you close it. So you're referring to this particular triangle. Okay, so I notice I have a 45, 45, and then look at this. This is a segment that intersects this segment here. I can see that this is 90, and this triangle here is also 90. Remember that special circumstance I was talking about, right? So since this is 90, this also has to be 90 degrees. You can assume that, okay? So what is triangle PQS? Well, I see that 90 degrees right there, so that has to be a right triangle. It has to be a right triangle. Okay, so now let's go ahead and take a look at triangle QSR. So QSR, and then, well, if I am looking at this triangle, since this is triangle QSR, and I see that 90-degree angle there, that means that this triangle is also a right triangle. Okay. Number, whatever this is, triangle PQR. So here's PQR, close it. What type of triangle is that based on their angle? Okay, well, I just want to go ahead and look at this particular angle. 45 plus 59, that is 14, carry the 1, 5 plus 9, that's 94. And look at that. Remember, that's an obtuse angle. Why is it an obtuse angle? Well, because this angle here is greater than 90 degrees, but less than 180. So just based on this particular angle, right, this triangle has to be acute. So this is an acute triangle. Acute triangle. Example 2. Classify the triangles in the figure by its sides. M is the midpoint of JL. This is my given. So if M is the midpoint of JL, so here's M, and this is JL, well, that means that it is going to split the segment into, so here's my midpoint, it's going to split the segment into two congruent parts, okay? So let's go ahead and figure that out. That means that I would have to draw a tick mark here and a tick mark there, okay? So that means that this whole, so we know that the measure of JL is 1.5, okay? And 1.5 divided by 2, because this and this are congruent or equal to each other, this has to be 0.75, and that is 0.75. And remember, 0.75 plus 0.75 is 1.5, okay? All right, so let's go ahead and, oh, I just noticed something. Since this is 0.75, right, and this is 0.75, I can go ahead and draw that tick mark there as well. So one tick mark there as well. Okay, let's go ahead and take a look at these things. And I'm classifying the triangles in the figure by its side, so I'm going to be using one of these things, okay? So triangle JKM, close it. These sides are congruent, so I can go ahead and say that this is an equilateral triangle. And then triangle KLM, close it. These sides are congruent, so we have at least two sides. That means that this is an isosceles triangle. And then lastly, J, K, where's L? L is right here. So I'm looking at this side, and this whole side. These sides are not congruent, so this has to be a scalene triangle. Okay? Example 3. Find the side lengths of the triangle. So I look at my picture and I see that this segment, or this side, and this side are congruent. So I can say that segment AC is congruent to segment CB. And then now I'm in the language of geometry, this is in the language of geometry, this is in the language of algebra. So AC is equal to CB. So then I'm going to use the substitution rule, and I'm going to put it over here. So I have 4x plus 1 is equal to 5x minus 0.5. Then I am going to subtract both sides by 4x and then add both sides by 0.5. So I get 1.5 equals x. Okay, so that is what x is equal to. Oh, okay, so I already figured out what x is equal to. So x is equal to 1.5, but it's asking me to find the measure of AB, AC, and BC. So note that AC is 4x plus 1, so I'm going to go ahead and replace the x with my 1.5. So I have 4 times 1.5 plus 1, so that should give me 7. Okay, so we know that AC is 7, and notice that this segment and this segment are congruent. So this also has to be 7. So BC is also 7, okay? But I don't know the length of this side, okay? So I'm going to have to do 9 times 1.5 minus 1, and that's going to give me 12.5. So that is how long AB is. It's 12.5, okay? And what type of triangle is this based on, the figure? Well, I can see that originally it has these 2 tick marks here, so this has at least, or really, but 2, right? It has 2 congruent sides. This is an isosceles triangle. So I'm going to say isosceles triangle, okay? So IT. All right. Example 4, find the side lengths of the equilateral triangle. FG is equal to GH is equal to FH is equal to, okay. So find the side lengths of the equilateral triangle. And that means that all sides congruent. So that means that since this is an equilateral triangle, this, and this are congruent. And I can go ahead and set up my equation. And just based on looking at these expressions here, they all have a y, right? And then they have just whole numbers without variables. So it doesn't matter. You can choose your adventure. You can set up the equation how you would like. You can set this and this equal to each other, or you can set this and this equal to each other. It doesn't really matter. I like to choose the one that makes my life easier, so maybe this and this I will set equal to each other, and it's going to be, okay, so we say that segment VG is congruent to segment GH, language of geometry, FG equals GH, language of algebra, substitution rule, 2y plus 5 equals 3y minus 3, so I get 8 equals y. Okay, and that's why I chose that one, because if I subtract both sides by 2y, I get y. I don't have to do anything else. So y is equal to 8. Now, it's asking for the measure of these things. And notice that this is an equilateral triangle, meaning that all sides are congruent or all sides are equal, right? So I can just pick one. And the one that I'm going to pick is this side over here. So 3 times 8 minus 3, 24 minus 3, 21. So this side here is 21. Okay, that's how long that side is. So that means that this side here is also 21, and this side here is also 21 because it's an equilateral triangle. That's my answer. the triangle sum theorem states that the sum of the measures of the angle of the triangle is 180, right? So the measure angle A plus the measure angle B plus the measure angle C is 180 degrees. So this plus this is equal to 180. The triangle sum theorem is just these angles, all three angles add up to 180 degrees. So example 1, find the measure of each of the numbered angles. Okay, so there is one big fat triangle right there, but you can see that this big fat triangle actually consists of two triangles here. One triangle here and another triangle here. So let's go ahead and figure out the measure. Okay, so notice that there's 28 degrees, 71 degrees, 57 degrees. That's how long each of those angles are. But this one just says 3, 1, and 2. That means that this is called angle 3, angle 1, angle 2. It does not mean that this angle is 3 degrees, this angle is 1 degree, and this angle is 2 degrees. So please make sure that you don't confuse yourself. Again, this angle is not 3 degrees. It's the name of that angle. Angle 3, angle 1, and angle 2. Okay? So, let's go ahead and figure out how long these angles are. Really, the easy one here is to figure out what measure angle 2 is, right? Because I already have a 57 degrees, 71 degrees, and I'm trying to figure out what angle 2 is. Okay? So, what you can do is you can create an algebraic equation and say measure angle 2 plus 71 degrees plus 57 degrees is equal to 180, because remember, these angles here add up to 180 degrees, right? So what you can do here is I'm going to combine the like terms. So measure angle 2 plus that should be 128 is equal to 180. So what is the measure angle 2? Well, 180 minus 128, that is 52. So this is how long measure angle 2 is. So that's 52. And I'm going to write that on my answer, or fill in the blank with that answer. Okay, so now I'm in this territory because I got to go ahead and figure out what 1 and 3 are, right? But the confusing thing here is that this triangle, the only thing that that'll be helpful is this 28 degrees. But notice that I have this 57 here and I have this angle 1 here. And I notice that this actually forms a linear pair, right? Because I have these two angles that are adjacent to each other, and essentially they're just stuck, right? These angles are stuck together. So this is basically a linear pair, which means that these angles add up to 180. So I can do 180 minus 57. And let me go ahead and figure out what 180 minus 57 is. That should be 123. Okay. So this angle here is 120 degrees. That's measure angle 1. And to figure out what measure angle 3 is, well, since again this triangle adds up to 180 degrees, right? So to do that, I can do the measure angle 3 plus 123 plus 28 equals 180, and I can combine the like terms, and that is going to give me, well, what is that going to give me? Because I have no idea. Let me see. I don't have my calculator. 123 plus 28, that's 151, which is equal to 180. So the measure angle 3 is 29. Okay, because I'm basically using the subtraction property of equality right there. So this is 29 degrees. Okay, awesome. Okay, so we got some vocabulary words that you need to know. So an exterior angle means that it's formed by one side of a triangle and the extension of any adjacent side. Of any adjacent, abbreviate that, adjacent side. Okay? And then the remote interior angle, that means that angles not adjacent to the exterior angle. Okay? So here is an example of an exterior angle because it's outside of the triangle, right? It's outside of the triangle, and it is basically an extension of any adjacent side. Okay? And the remote interior angles, they are angles not adjacent to the exterior angle. So 1 and 2, right? Or sorry, not 1 and 2. 1 and 3 are not adjacent to the exterior angle. So this is the exterior angle, right? And notice that angle 1 and angle 3 are not next to that angle. So that's a remote interior. So these are remote interior angles, and this is my exterior angle. It says right here, angle 4 is an exterior angle of triangle ABC. Its two remote interior angles are angle 1 and angle 3. Okay? Theorem 4.2 states that the exterior angle theorem is the measure of an exterior angle of a triangle is equal to the sum of the measure of the two remote angles. So this right here, this angle is outside of that triangle, right? And that's my exterior angle. So this is my remote exterior angle. Okay? And then my two remote interior angles. Again, interior means inside, right? So it has to be not adjacent to the exterior angle. So here's the remote exterior angle, and angle A and angle B are not next to this angle here. So it's the measure angle 1. I know it says right here, but I'm going to rewrite it. Measure angle 1 is equal to, so this is my remote exterior, is equal to this angle plus this angle. Okay? So that's equal to the measure angle A plus the measure angle B. So let's go ahead and take a look at example 2. Find the measure of each numbered angle. So, to figure out what measure angle 1 is, actually, let's take a look at this picture. Let's figure out the remote interior angle, or sorry, the remote exterior angle. So, this angle here is outside, right? So, this is right, this is my remote exterior angle. And these two angles here, right? So this angle and this angle are not close to this angle whatsoever. So these are my remote interior angles. And that applies to these two angles here as well. They are remote interior angles. So let's go ahead, because my what I wanted to do is to was figure out how long this angle was. And well, it's all inside a triangle. So 35, 75, and angle 1. So to figure out what angle 1 is, I just need to do. I'm gonna do the shortcut. I'm not gonna set up an algebraic equation. I'm just gonna do 180 minus 35 minus 75. And that's just basically 70 degrees. So the measure angle 1 is 70 degrees, okay? To figure out my remote exterior angle, well, it's just basically the measure angle 2 is equal to these two things over here, right? So I can do 35 plus 75, right? Because again, the measure angle 2 is equal to these remote interior angles, so that is equal to 110. Okay, so that's 110 degrees. All right, so now what I want to go ahead and do is look at, and also, by the way, I just want to make sure we understand something. Actually, never mind. I had this whole idea. Actually, no. I know what I'm trying to say. Okay, so you notice that we said that measure angle 1 was 70, right? Well, to figure out what angle 2 is, well, y'all, this is a linear pair. You can literally just do 180 minus 70, right? And that's just going to give you 110 because these two angles are supplementary and they add up to 180 degrees, okay? Yeah, that was what I was trying to go ahead and say. Okay, so now trying to figure out what angle 3 is, the measure angle 3. Well, notice that to figure out what angle 3 is, you know that you already know what the remote exterior angle is, right? You already know that the remote exterior angle is 110 and is equal to the remote interior angles, right? So basically I can just do this. I have measure angle 3 and 28 degrees, which is equal to 110 right here. Right? So I can just go ahead and set this up as an algebraic equation. So 110 is equal to the measure angle 3 plus 28, solve minus 28 on both sides. So you get 82 equals measure angle 3. Okay? So that's how long that angle is. It's 82. Okay? All right. If I were to give you, so let's say you have a small angle, right? And then you close it. Well, what's the relationship between this angle and this side? Well, let me go ahead and draw another picture where the angle is obtuse. So I have an obtuse angle. What do you notice about the side? What's the relationship between the angle itself and the side? The angle itself and the side. I'm gonna draw one more. You see that? So if you didn't notice, look, the smaller the angle, then the side opposite to this angle is going to be small. The bigger the angle, then the side opposite to that is going to be big. And you can see that with this. The bigger the angle, that the side opposite to that angle will also be large, okay? Let's go ahead and talk about equalities in one triangle. We know that if all sides of a triangle are congruent, then all the angles are also congruent. What relationship exists if the sides are not congruent? Examine the longest and shortest sides and the smallest and largest angles of a scalene obtuse triangle. And you know, that was this was basically what I was talking about before. It's basically this stuff that we mentioned, right? So the longer the angle, then the side opposite to that angle is going to also be long. The smallest the angle here, then the side opposite to that angle is also going to be a short side. So let's go ahead and fill the blanks in. The longest side and the largest angle are opposite to each other, and the shortest side and the smallest angle are opposite to each other. Okay? So here's the relationship. If one side of a triangle is longer than the other side, then the angle opposite. If one side of a triangle is longer than another side, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side. Okay? So we can go ahead and look at this stuff. If one angle of a triangle has a greater measure than another angle, then the side opposite the greater angle is longer than the side opposite the lesser angle. Okay, and then we can go ahead and take a look at that. So let's go ahead and put the angles in order from smallest to largest. You're going to name the angles, okay? So we have these sides here, right? So again, the smaller the angle, the smaller the side, or if you say the smaller the side, the smaller the angle, okay? So we're gonna name the angles from smallest to largest. So we can see that this is my smaller side, right? So this means that the angle is also small. So angle Q is your smallest angle from this triangle. And then notice that the second smallest side here is 8.8, and the angle opposite to that is R, right? So angle R is your second smallest side. And then lastly, we can see that 9.1 is your largest side. So that means that the angle opposite to that side is angle P. Okay, so this is from smallest to largest. Okay, now we're gonna go ahead and put the sides in order from shortest to longest, and you're going to be naming the segments here. So this is not filled all out because we have 45, 56 in this blank, and I'm going to tell you that this is 79 degrees. Okay, so 79 plus this and this is equal to 180. Remember, triangle adds up to 180, so you should be golden on that. Okay, so we're naming the sides in order from shortest to longest. So the smaller the angle, then that means the smaller the side. Okay, so segment FG is the smallest side. And then the second smallest angle is 56. So what is the conclusion? That means that segment FG, wait, what did I write? Oh, I meant to write FH. I'm so sorry. So this is this side here, right? So it's FH. And then over here, that means that FG is the second smallest side. And then lastly, the biggest side here is GH, okay? So we will say GH.